Hello. Hello. బాగుంటుంది సార్ ఏం చేస్తుందా గురించిగా చేయలేదు నాకు రాలేదు నేను క్లాస్లో ఉండదు సార్ ఓకే ఓకే Yes, like me, just I have received your message on it. Just okay, let us see later on. Now, just we have some notes for the students. Let us discuss this one. Yeah, so we have some conceptual discussion of stationary waves, right? So, what are stationary waves, and how to form the stationary waves, and how to understand the formation of stationary waves in a stretched system. First of all, you can say stationary waves are what are stationary waves? The waves which confine between two obstacles or need to uh, we can say constants is called stationary waves. If there is no obstacle or a constraint, the waves will propagate or travel along. So these waves will be called as progressive waves. So these waves are called stationary waves. What are stationary waves? The waves which confine between any two uh, obstacles or constraints. Any point you can see. They are called stationary waves. How to form the stationary waves? Say we know that if you have a wave like this, is called it is traveling continuously in this direction without any a constraint here or obstacle. These waves are called progressive waves. Whereas if here say for example, it is a stream and if it is fixed here, these waves after coming here, they reflect back and this is if you say this is incident wave, the reflected wave will change the phase by 180 degrees and it will travel like this. This will be a reflected wave. This will be a reflected wave. So this is incident wave. Sorry, this is incident wave. This is reflected wave. Okay, this is reflected wave, right? So incident wave. This is incident wave. This is a reflected wave. Reflected wave. So this reflected wave and incident wave will combine together or superpose together and it will give stationary waves. Okay. To understand this mathematically, let us consider instant wave is a progressive wave. If it is moving along positive x direction, it can be represented as yi is equal to a sin kx minus omega t. Y is a reflected wave. It is represented as a sin kx plus omega t. It is moving in negative x direction. both are having same amplitude, same frequency, and same wavelength. Here wave number is 2 pi by lambda. So both will have same wavelength also. Such waves, if they interfere or superpose, we will get a resultant wave. The resultant wave will be stationary wave. How to understand the variation, the different parameters of stationary waves is, so by considering the mathematical expression for it, by using this relation y equal to y1 plus y2 r by I. It is a superposition of incident wave and reflected wave. So here actually, if you use these two, a is common, a out, then sin kx minus omega t plus sin kx plus omega t, they will be in the form of sin c plus sin d form. By using the formulas 2 sin c plus d by 2 into cos c minus d by 2 form, we get 2a sin kx into cos omega t. Here, this will gives you the amplitude of resultant stationary wave, this entire thing. That means the amplitude will changes with position x, and this is a time function, this is x function. That means the amplitude is the position of x. So amplitude of the stationary wave will changes with time. That means here this is a stationary wave. Amplitude of this stationary wave will be 0 to at some points, and it increases. This is the amplitude. It increases, then it becomes maximum at some points, again decreases, and it becomes minimum or 0 at some other points. Like that, it will be varying as x changes. Amplitude of this is amplitude of stationary waves will changes. So here we can say that this, as this is, if you observe, this is not, this is the form of ax plus bt form, ax plus bt form. So this two will be progressiveness, but this is not in the form of, if you observe here, as this is not in the form of a function of ax plus or minus bt. It is not a progressive wave, so it is a stationary wave. You can conclude that this is stationary wave. And whether it is a wave or not, if you want to clarify, you have to use one condition, that any equation which satisfies this condition will be called as a wave. That means if it is y equal to, stationary wave is equal to a sin kx into cos omega t, if it satisfies rho square y by two square equal to b square rho square y by 2 x square, then it can be called as a wave equation. But this also will satisfies this equation. You can call as equation 1. With RK, you can call as equation 1, 2, this is 3. This satisfies this equation. So hence we can call it as a wave, but it is not a progressive wave because it is not satisfying this equation. So this wave is called stationary wave. And in stationary waves, we come across these points. These points called nodes and antinodes. What is node and what is antinode? So let's see. The points in stationary waves where the amplitude is minimum are called nodes. Amplitude is minimum are called nodes. Okay. Whereas the points in stationary wave or positions in stationary waves where amplitude is minimum or maximum are called antinodes. Antinodes. Right? Node amplitude will be minimum or zero. Amplitude should be minimum. Amplitude is minimum or zero. If amplitudes of both individual waves, interfering waves are equal, then it will be zero. Otherwise, it will be minimum. Antinodes, amplitude should be maximum. Amplitude is maximum. Should be maximum. Okay. So these points are called antinodes, and you have to know some important points about these nodes and antinodes. That so the distance between any two successive nodes, distance between any two successive nodes, any two successive nodes, nodes is lambda by 2. That means if you observe in the again in this figure, this is node, again this is node. Okay, this will be called as one loop. So this from here to here will be called as one wave. So the total distance is called a wavelength, but here half of this gives you one loop. So this distance will be called as lambda by 2. Otherwise, you can say between one antinode and this antinode also will be lambda by 2. So distance between two nodes or two antinodes. We need two successive nodes or even two antinodes. Here also distance between two successive antinodes is lambda by 2. And from the above expression, we can find the positions of nodes in general. and this gives the magnitude, what is that, amplitude of stationary wave. This when this is maximum,
Mass of
deionized helium plus 2 atom travels at right angles to the magnetic field of reduction 0.4 Tesla with a velocity of 10.5 meter per second. Describes circular radius r. The proton traveling with the same speed in the same direction in the same field and describes circular radius. Doubly ionized helium. So what you can understand, helium is nothing but He24, right? So its charge will be uh, charge of helium will be 2 times charge of proton. Is it doubly ionized? So it is having, let's say this, because of this, charge will be what you have to understand is both are positive particles, positive charged particles. So usually uh, helium can be expressed as He24. He24. This represents number of protons. So charge of alpha particle is 2 times charge of proton. What is doubly ionized means 2. We have removed, what is that, plus 2 means, what is it means, so, positive charge or negative charge. You should have the basics, otherwise you cannot understand all this terminology. So doubly ionized means you have ionization means removal of electron. If 2 plus means 2 electrons are removed. So what is that?
one.
Mm. So you can see the charge of overall charge of alpha particle should be this. So and hence what about the mass? This is the mass number, 4 units mass. But when if you compare with the proton, proton charge is just charge of proton is E, whereas mass of proton is just M. M is 1.67 to the power minus 27 kg, whereas it is 4 times that. Mass of alpha particle is 4 times mass of proton. So these masses are different, charges are accordingly have to consider. Yes. So now it is mentioned that both are now this is traveling at right angles means of course it is equal to 90 degrees to the magnetic field. Magnetic field is given B of 0.4 Tesla with a velocity of 10 power 5 meters per second. Describing the circle of radius R1 is equal to R. It is moving with a velocity of V is equal to 10 to the power 5 meters per second. Describing circular radius is the proton traveling with same speed in same direction means proton with the same speed in same direction in the same field as well, in the same field, describe the circle of what radius? R2 is equal to what for proton. So what you can understand here is they're all same except what is this? Masses. So you can understand the relation between what is this?
Radius.
Uh, your relation between radius and mass is R is equal to, we'll say, and any other parameters are mentioned here. There's in the same magnetic field. So usually it is nothing but mu by R is equal to mu by cubic. Velocity is same. You mentioned at the same speed in same field, and if you consider this doubly ionized, same it is equal to m. R equals R proportional to m. So R2 by R1 is equal to M2 by M1. So R2 is equal to M2 by M1 into R1. M2 is mass of R1 is which one you have to consider? R1 is proton and R2 is this thing. So proton radius of proton circle you want, right? So let us see, this is proton case. First one is helium. So m2 mass of proton is mass of proton by mass of helium is 4 times mass of proton into radius r. So it will be r by 4 or r by 2. Hmm? So we have to consider that case. Actually, the potential difference is when it mentioned about potential difference, then we have to take it as a under root of m into kinetic energy in terms of kinetic energy you have to consider. In terms of kinetic energy, we say radius is equal to mv by what qb is equal to p by qb. In terms of kinetic energy, you can write as 2mk by qb. Right? If velocity is constant, means mass is changing, right? Okay, does they mentioned about energy and not mentioned about energy, right? So they mention is whether energy or potential, then you can use this. Otherwise, you have to use this only. R by 4 only we should get. So then this should be wrong. Okay. So if it is mentioned like the energy is constant or potential difference is constant, then it depends on root here. Otherwise, it's directly proportional to m only. So this condition is given, then only I have to consider this. Okay, that's it. So you can cross. Maybe sometimes they will do consider the wrong conditions. Concept. We are discussing the concept. You would like to attend?
Sir?
Conceptual discussion is clear.
Yes, sir.
Hmm?
Yes, sir.
So just let's finish then this.
Okay.
So here we have to remember that. Here we have to so the next very important point you have to remember that from this mathematical expression, this 2a sin kx represents the amplitude of stationary waves. When the amplitude is minimum, those points of minimum amplitude are called nodes. The points of maximum amplitude are called antinodes. So from this you can say that as 2a sin kx is amplitude of the stationary waves. So when this is minimum, we'll get nodes. Minimum means value of this would be, so for what value it will be minimum? When sin kx is minimum, sin kx will be minimum value of this is 0. So it can be equal to 0. For what value of this it can be 0? Actually, this entire kx will be equal to 0, pi, yes, 2 pi, 3 pi and so on. That means kx should be equal to integral multiple of 2 pi, where n can take values n equal to 1, 2, 3 and so on. So where k is being number, it can have values of 2 pi by lambda, right? If you take that 2 pi by lambda into x is equal to this 2 pi by lambda into x is equal to n into 2 pi. If you take 2 pi cancel, then from this you can see that positions of nodes is equal to n into lambda. Sorry, is this 2 pi by lambda, and this is not integral multiple of 2 pi, integral multiple of pi only. It means for pi also it can be 0, right? So integral multiple of pi. What is it? Integral multiple of pi. Okay, so pi cancel, 2 will be there, so x is equal to n into lambda by 2. N into lambda by 2 means at x is equal n equal to n can have values 0 onwards. N can have values 0, 1 to 3 and so on. So n is equal to 0, 1, 2, 3 and so on. N equal to 0, first node will get. So if you see this waveform, actually if a wave is going like this, right, and after reflection it is coming back like this, right? And so at x is equal to 0, n equal to 0, here you will get node, right? So then at x is equal to lambda by 2 you will get again one more node. Then at next one 2 lambda by 2, that is lambda, or 2 lambda by 2 next node, 3 lambda by 2, like this. The integral multiples of lambda by 2 positions, this is x in terms of lambda, so we get nodes. So this gives the positions of nodes. Whereas antinodes, what are antinodes? Positions of maximum amplitude in stationary waves. Positions of maximum amplitude in stationary waves are called antinodes, right? These antinodes, again, the distance between, this is one antinode, this is one antinode, the distance between them is called what do you call, lambda by 2. Successive antinodes and positions of these antinodes, how to find, as this is the 2a sin kx represents the amplitude of the resultant uh, stationary wave. This amplitude will be maximum. This amplitude maximum value of this will be, you will get maximum value of this for maximum value of sine. For sine kx will be maximum, this maximum value of this can be obtained when sin kx is maximum. What is maximum value of sin kx? 1 plus or minus actually 1, right? So for what value of kx we can have sin kx is 1. So this can be obtained for kx is equal to 90 degrees, 90, so 270 like that, right? Or pi by 2, 3 pi by 2, 3 pi by 2, 5 pi by 2, etc. That means if again if you simplify this k by putting k value as a 2 pi by lambda, 2, this implies 2 pi by lambda into x is equal to this. You can let us say it is a odd multiples of pi by 2. Odd multiples means you can take it as 2n minus 1 or 2n plus 1. But 2n minus 1 means n equal to 1 to 3, 2n plus 1 means n equal to 0, 1 to 3 and so on. So 2n plus 1 into pi by 2, where n equal to 0, 1 to 3 and so on, where pi gets cancelled. Hence you can say positions of antinodes is given by 2n plus 1 into pi, sorry, lambda comes here, lambda by 2 is there, this 2 also comes here, by 4 at these positions. That means where n takes values 0, 1, 2, right, 3 and so on. That means at 0 lambda by 4, 1, 3 lambda by 4, 5 lambda by 4, at these positions 0 n equal to 0 means lambda by 4, lambda by 4, then this is 3 lambda by 4, 5 lambda by 4, these positions will get antinodes. These are the positions of antinodes in case of stationary waves.
3 lambda. Okay.
N equal to 0, 0 into 1, into 0 plus 1, so 1 lambda by 4. 1 means 2 into 1, 2 plus 1, 3 lambda by 4. 2, 2 into 2, 4, 4 plus 1, 5 lambda by 4. Like that, odd multiples of lambda by 4s will be the positions of antinodes. Right? So related to these stationary waves, we need to discuss a few terminology. Those are nothing but what are harmonics, what are overtones, and what is octave, etc. You see this one. This one written here. Written here.
It should be 16 kilos.
Should be.
It should be 16 kilos.
Let's check this. Breakdown is rotating along separate path with kind of kinetic key. The unit of magnetic field P. If the magnetic field is made four times, the kinetic energy of rotation of the proton is kinetic energy and magnetic field relation in the same path, same path. So you can say R is equal to, in terms of kinetic energy, is square root of 2mk by qb, right? So the proton is rotating along a central path with kinetic energy k. Initially, what is that? Initial kinetic energy k1 is equal to k. So q1 is equal to q. In uniform magnetic field B, so B1 is equal to B, right? Q, B, K, and proton mass of proton is M. Now the same proton, if the magnetic field is made four times, but all other terms are same, means the particle is same. Q2 is Q only, M2 is M only. If magnetic field B2 is four times, 4B made four times, the kinetic energy of rotation becomes what is K2 is the question, right? So what you can understand here, all Q and B is Q and M, Q and M are same. These two and R is also same because it is mentioning that mm, we are mentioning that only these are same. So what you can say, R proportional to K root K by B, right? So from this, can we say is of course it is mentioned about if this any of this changes, it is also will change. But if B2 becomes 4B, what will be the kinetic energy provided if the magnetic field is made four times the kinetic energy of rotation of proton, kinetic energy of rotation of proton actually speaking actually without this you can say R is equal to mv by qb. If mass same, charge same, speed they didn't mention about the speed. hmm, Magnetic field becomes this much means actually you can see this is R is proportional to V by B, R root of K by B, so that when this changes as it is proportional to K by B, it has to be, this has to be constant. That is what you have to understand. It is nothing is mentioned about means. So for this to be constant, how this has to be changed? This is four times. It is becoming four times. Consider this is B proportional to root K. K1 by K2 is equal to B1 by B2 square. Then it will be so if that is the condition, if you consider, then it is supposed to be B2, we have taken it as a 4B by 4B, so it should be 16. If K1 is K, then K2 will be equal to 16K. But actually speaking here, if this is 16K, then this is 4b, then it remains constant. That is what you can say if r is constant.
But they have mentioned
It is not mentioned about anything about this. Means
it should be 16
yes,
kilometers.
yes. Then it should be 16. If it is constant, then it is 16. It is not mentioned means just have to consider the other conditions, boundary conditions also. There you have to cross check this. Well, let him know. So actually, if he is constant, means it is 16. Okay.
Thank you. And this question is 43rd one.
So
43rd one is
what is given here is the standing wave setup in a medium is y is equal to 4 cos pi x by 3 pi x by 3 into sine 40 pi 40 pi into t 40 pi into t, where x and y are in centimeters. This is also important, where x and y are in centimeters in CGS units. X and y are in centimeters and t is in seconds. Okay, then the velocity of the medium particle is velocity of the particle velocity of the particle. What is velocity of the particle at x is equal to 6 centimeters and t is equal to 1 by 8 seconds? This is displacement of particle. So velocity of particle is nothing but dy by dt. So this is x term. You can keep this aside. It is equal to 4 cos pi x by 3 into this. Only have to differentiate. Differentiate with respect to t. What will becomes sign becomes cos 40 pi into t. This is a constant. So this into this constant will come into 40 pi. Right?
yes,
This is like sin omega t becomes cos omega t into omega. This is omega 40 pi. Right? Now 40 pi into 4 is 160 pi. Right?
yes, sir.
160 pi into cos pi x by 3 into cos 40 pi t. You are asked to find what is this particle velocity at x is equal to 6 and t is equal to 1 by 8 centimeters. Okay. Then what if you substitute it here, you will get 160 pi into cos x is equal to 6. If you put x value 6 here, 3 to 6,
2 pi
so
it
2 pi
becomes
cos 2 pi into cos t is equal to 1 by 8 means 40 pi into 1 by 8
cos 5 pi
8 5s 8 5 pi. So if you observe the cos waveform, this will be the cos wave. One wave, two waves like this. So it is equal to 160 pi into cos 2 pi. This is 0, 90, 90, 180, 270. This is 2 pi, 360. So cos 2 pi is 1. So this is 1. Then what is cos 5 pi? It is 2 pi. Hmm? Then this is 2 pi, 4 pi, 4 pi. Then this is one more wave. This is 6 pi. Here up to here 5 pi. 5 pi is minus 1. So it should be minus 1. This is 1. This will be minus 1. Did you understand?
yes.
So what you can understand from this?
What can be based on?
So you will get minus 160 pi. Minus 160 pi. All are in CGS units only. Centimeter per second. But answer is given as the key is given as this. And just cross it once again. Just we velocity of the particle only, right? Velocity of the medium particle is dy by dt. Wave velocity is dx by dt. Yes. Velocity of medium particle, medium. Question number 3. Have you checked the key?
Sir?
Have you checked the key?
Yes, sir.
Check once. Up to 3, right? 43, 4. 43, 4. Okay. You are marked on it.
Yes. No, sir. Preeti only marking it. We have
Okay.
informed her
43,
also.
4. Okay.
Okay, sir. Thank you, sir.
Right. So we are doing this one, right? Yeah. So next part is to understand the stationary waves, especially frequency of vibration of the stationary waves in stretched string. Stretched string. You need to have an idea about few terminology like what are harmonics, what are overtones, what is an octave notes. Harmonics are nothing but integral multiples of fundamental frequency. Fundamental frequency is the basic frequency with which it will vibrate in first mode. The basic frequency with which it vibrates in the first mode is called fundamental frequency. What is that? We'll see one day. Overtone frequencies means the frequencies other than the fundamental frequency or first harmonic frequency. Okay, the harmonics other than first harmonic are called overtones. Means second harmonic will be called first overtone, third harmonic will be called second overtone, like that. Like octave means the tone whose frequency is double the fundamental frequency will be called as octave. Perfect. So uniform electric field and this question number 1, right? The uniform electric field and the uniform magnetic field are produced pointing in same direction. Let us say x direction, horizontal direction. Electric field and magnetic field. If an electron is projected with its velocity pointing in same direction, then what you can understand, magnetic field is acting in horizontal. If it is projected in the same direction, what will be the force due to magnetic field? Zero. Zero. Force with electric field, QE. Only force acting is electric field.
Then X axis means the force. Finally, the
It
velocity
will move in straight line.
then X axis.
X axis only.
But they also told they will reverse in direction.
What is mentioned here? Oh, electron.
Negative.
Electron, negative charge. Yes. So if it is a positive charge, it will move in the direction of the electron is a negative charge particle. So force will be minus QE. So if you project it, it will go and stop and it will reverses the direction.
So the velocity decreases.
Actually, first it decreases and it stops. Then it starts going on with increasing velocity. It goes with the acceleration. Force means it will undergo acceleration.
Proton means
It will continuously move in the same state.
at the time velocity will increase or be
Yes. Force, constant force is there means acceleration will be constant. Constant acceleration means velocity going on increasing with constant rate.
constant.
2, 4, 6 like that it increases.
Then this concept.
So just have discussing this once. So the first aid concept.
Yes. We, how they are taking it?
Helical path.
No, sir. Here, they told that anti-clockwise for outward direction. How they are told that outward direction anti-clockwise?
The direction of not anti-clockwise. Direction of force. Charged particle enters perpendicular to the magnetic field.
Negative charge.
Negative charge direction of its circular motion. So what you can understand here is if direction of magnetic field is outwards, direction of circular motion will be anti-clockwise. How it is anti-clockwise is the question, right? So here we have magnetic field. Here we have magnetic field, and a charged particle enters in the magnetic field. So what you can understand here, first case, a charged particle Q enters perpendicular to the magnetic field, and magnetic field is outwards. Outwards means dot, 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 like this, right? So outward. So the charged particle enters with velocity v, enters with like this. Okay. When it enters, the moment it enters, the what is the direction of force here? It tried to moving in the straight line path, but because it is moving charge in the magnetic field, a force acts on it. In which direction the force acts? V cross B. V cross B. V is V. B is outer. Not like this. Outward, right? B is outward means V cross B. So B will be down. Force will be downward direction. Force acts in downward direction.
This like
No, negative charge, right? Not positive charge. If you consider positive charge outward, positive charge enters an outward magnetic field like this. Force acts downwards, so it instead of moving in straight line path, it will deviate. This is the here is the charge. Instead of traveling in straight line path, it will deviate like this, and again it will deviate like this, and again it will deviate like this, and it undergoes this path. This path. What path? Clockwise direction.
sir, how we are saying this force and
Force is downwards. This is force. Downwards, not outwards. This is a magnetic field.
velocity.
Stretch the fingers of right hand along V vector and curl the fingers into V vector and simultaneously stretch the thumb. So curl and thumb. Curl and stretch the thumb. So you cannot keep and you cannot curl like this. So you have to conveniently have to put your thumb. So if you curl like this and stretch the thumb will be downwards. So force is downwards. So it will deviate in this direction and it undergoes clockwise direction. Yes, if it is negative, so force is here F is equal to QVB plus QVB. If it is a negative charge, minus QVB. That means instead of deflecting downwards, force will be a negative charge. If you send a negative charge here, this is positive charge. Negative charge, force will be in upward direction, so it will deflect and undergoes a path motion like this. What is this? Anti-clockwise direction. Anti-clockwise direction. Positive charge, clockwise direction. Inward means, say if you say this is inward, uniform. So first say negative charge. So let us say first positive charge plus Q enters. This is V. B is into V cross B. Force will be upwards. So force will be upwards. So it now positive charge will undergo anti-clockwise like this. Anti-clockwise positive charge in inward field. Negative charge here it undergoes this kind of motion clockwise. like this. Okay, so that is how it will undergo according to right hand thumb rule or palm rule.
Outside means this in the palm and inside which is
So outside means will be in this direction.
question number 17.
So which one? This one. What is it?
Some
Magnetic
by chance.
magnetic field. Biosavatra, see, doing this you have completed force. Okay. Force on moving charge. Force on moving charge. Have you done this?
Also the class in the so already
Better you do it this way. Because we are doing this concept. If you did then this, then it will be more systematic, right?
just plan to complete
And that's
night
all.
night I will complete
Only this exercise.
almost
Or all exercises.
all exceeds this one completed. Do level
That's what. Instead of that, you go through the same way you are doing it. Then you will be in sync with everyone so that you can discuss the questions also. You can spend the time for discussion. Otherwise, it completely will deviate. First, try to finish this. Okay? Good time up.
yes.
So, harmonics means the models which are having integral multiple of fundamental frequency are called harmonics. Right? Overtones means the harmonics which are having frequencies other than first harmonic are called overtones. That means second second harmonic onwards you have to consider. First harmonic you have to exclude. Second harmonic frequency will be called as first overtone frequency. First overtone frequency. Third harmonic is called second overtone. Right? Nth harmonic is called n minus one overtone frequency. Plus octave. Octave means the tone whose frequency is double the fundamental frequency. The tone whose frequency is double the fundamental frequency is called octave. If you are asked to find the what is it, octave in a particular case, you have to find the fundamental frequency and multiply with that with 2. That will give you the octave frequency. Octave. Right? So these are few points. Actually, again, that you can understand in case of statistic, which is fixed at both ends.
This is explained.
Yes. Yeah. So this is when both ends fixed, only one end is fixed. One end is fixed means and road always in the common field. This okay.